My name is Professor Luis de Jesús Báez. I'm an assistant professor in the Department of Chemistry at the University at Buffalo. The technology funded by TAF is related to conductive inks, specifically copper-based, for a more sustainable, stable, and molecular aspect of it. The conductive ink currently being used are silver-based, and silver right now is a little bit expensive. And so as we move into copper, which is more sustainable, lower price, that could really help move the market and the technologies based on conductive inks. When we think about conductive inks, there's two words there, right? Conductive inks. Conductive means that you're able to transport either electricity or temperature through a specific frame. And inks is that you can print it, right? Similarly, when you use a printer. And so what we're trying to do here is truly learn how can we create flexible inks that once you print it, they can conduct a specific temperature or electricity. And when we think about adhesion, is how stable it is on a substrate. And so sometimes if you have wood versus something a little bit more ceramic, adhesion changes because due to the substrate. And so what we're trying to do is find those little aspects that we can apply in both something as wood or ceramics and still maintain the conductive property of the technology. TAF is different to other funding agencies because it really promotes that industry academics connection. And then it brings about a perfect symmetry of what the challenge is for a specific company with the fundamental aspect of that really motivates most of us scientists and professors. And so the TAF, I think that really creates that equilibrium between those two parts, which I think is a little different to other funding agencies, which may focus more on either the technology itself as an application or the fundamental as the preface of the technology, right? This is, I think, this more symmetrical in that aspect. Advancing this technology is actually, I look into a future where cell phones are not solid and they're actually very flexible, right? Or computers are more flexible as well, so we can store it better, right? So, and for that, we need ways to conduct electricity through a frame that is not on a solid padlet, right? And so that's part of the initiative or the work that we're trying to do. As we advance this technology, we can go into more flexible wearables or more flexible computer cell phones. And so I think that this is not just about how can we make this technology more stable, adhere better to substrate, or more molecular. It's also how can we then truly go into a more not solid future.